I think 300,000 homes a year is really, really ambitious.
Looking ahead about how my children will afford to buy a home, it's much more challenging for them than it was for me. That doesn't seem fair to me.
The thing is, houses are selling quickly, house prices are rising rapidly.
We're not building enough to meet current demand.
We've got a huge skill shortage in the industry.
Not a lot of people grow up through school wanting to be bricklayers.
And I don't think we've addressed it as quickly as we could have done.
Just remember, we're about reducing carbon, and every percent you reduce is a good thing.
Yes, we should have moved sooner, but it's better we're moving now than not at all.
For many years, the UK has not built enough homes to keep up with demand and expanding population. Since 2008, 2.1 million homes have been built in England, while the population has grown by 5 million. While it's essential to meet this demand, the country's home must also be low carbon, energy efficient, and nature friendly. This means how we build is going through the most significant change it has seen in more than 70 years.
I think in terms of housing numbers, we're not building enough to meet current demand. That means we need to scale up. But also there is pent-up demand from all the years when previously we weren't meeting demand either. And while that exists, prices will continue to be high.
New regulations introduced in the summer of 2022 are already driving down the carbon emissions of new homes. The future home standard will go even further, ensuring that all new homes will be gas-free and zero carbon ready from 2025. But to build the hundreds of thousands of homes we need each year will take a huge amount of resources and lots of people. Like many industries, house building has suffered from a severe lack of skilled workers for many years. The Home Builders Federation report that for every 10,000 homes built, we need a 30,000 strong skilled workforce. That's more than enough people to fill the O2 Arena. To achieve the transition to net zero, the Construction Industry Training Board believes we need to train an additional 22,000 people a year. One way to achieve net zero, build more quickly, and help with this skills shortage is through using modern methods of construction, known as MMC. The Zed House tested a range of advanced MMC techniques, building many elements off-site, halving build times, and reducing waste.
MMC is modern methods of construction, so that, for an example, timber frame building is classed as a modern methods of construction. When you look at MMC as opposed to traditional, it primarily involves taking things off-site, so components are coming to site pre-built. So for example, with a panelised masonry solution, your panels are pre-built off-site and they come as a full wall system that are then put together on site, which is similar to what we've done at the Zed House, where we've used a full brick system, which is similar to what you'd find on site, but everything was done off-site, so there was no bricklayer on site at all, no brick waste or anything like that.
The Quickwall product is a bricks and mortar masonry prefabricated walling system. So unlike lots of other modern methods of construction, it doesn't incorporate brick slips, it's actually full bricks, and really the innovative element of it is all around the way that it's manufactured and the fact that the panels are transported as a complete panel to site, but it still gives exactly the same look and feel as a traditionally brick built building.
You don't need as many skilled trades on site, less waste on site, it's a lot quicker, which is a massive advantage in terms of cost and skills. There's a lot less carbon in a lightweight cladding solution than there is the likes of a brick or block as well, so there's them advantages.
According to a study commissioned by the RAP, the construction industry uses 400 million tonnes of material every year, and within that, 100 million tonnes goes to waste. That's the weight of over 8.3 million double-decker buses combined. A study by KLH Sustainability comparing MMC and traditional construction methods concluded that there is a 45% reduction in material use and over 50% reduction in waste through using MMC. The other positives are Builds can be completed at least 30% quicker, 20% less workforce is required for the builds, it reduces heavy goods vehicles movements on site by 40%, and as panels are manufactured off-site, production can be localised to a specific area. However, outside of the environmental positives, what is the end benefit to the customer? Why should consumers care about the way a home is designed and constructed?
So the Zen House is a timber frame dwelling, so it's starting off from a really good position, and then it's clad with familiar brick. So you get that nice combination of energy efficiency from the timber frame and low embodied energy from the timber frame, as well as the familiarity of brick. And then they've used some interesting new materials in the roof, a very lightweight metal tile instead of the usual concrete tile. So they're exploring interesting new ways of delivering something which looks familiar, but actually has quite a lot of different things going on under the hood.
With building thousands of homes a year, how do we balance meeting demand and unlocking the benefits of MMC, while still ensuring each home has the individual design and character needed to make a house a home?
So when we think about modern methods of construction as applied to delivering homes at scale, one of the principles of modern methods of construction is to really think about things like mass customization. So we can see that when we think about a house or a modular build, we can combine it in different configurations, we can clad it in different ways, we can put different technology in it, we can paint it different colours. So there are lots of opportunities to bring that requisite variation in.
I'd say Zed House is a look into the not too distant future. It's not far away. Everything that they've got in the Zed House now is achievable. It's about, can you do it at scale? Can you do it at scale for 300,000 houses? That could be debated now amongst the skill sets that we've got within the builders, the installers, the service and maintenance engineers.
So how do we roll out Zed House on a large scale? We will know a lot more when we finish the research. There will be some niggling factors that didn't work. There will be some great lessons in there that we've learned along the way. And there'll be some things that we never thought about as part of the design or the installation or even the monitoring that we learn along the way as well. Zed House to me is a learning house. It's about learning what we need to do to meet that demand further down the track.
So the Zed House was really exciting because we were allowed and capable of building this first of its type and learn the lessons. But the one thing is it's outside, so we don't have a controlled environment. And one of the important things is, how will this house perform in 2025, 2050, 2075?
One of the natural successors to Zed House would be a project that Saint-Gobain and Barratt's are working on in Energy House 2.
So the space that we're sat in now is the Energy House 2 project, so it can go up to plus 40 degrees down to minus 20 degrees. It can rain, wind, snow, do whatever you like. And the beauty of that is we can see how the systems operate under different weather conditions with the university and within this laboratory that we're essentially sitting in right now.
So we'll take the lessons from the Zed House, put it in the Energy House too, but actually we'll be able to have a controlled test in an environmental chamber that will tell us what will it be like to live in that house in 2050 with hotter summers and colder winters, for example.
And then we can say what happened to that building and what changes do we need to make to it to counter or react to any climate change effects that we get along the way.
It doesn't stop there, because of course we're also looking at Zed houses on live sites. So we've got a number of sites where we're actually delivering the Zed House. And again, in those projects, we're looking at different things. So one's been very driven by water. Another will be driven maybe by embodied carbon, always with operational energy as the foundation.
I think as the Zed House has been successful in the sense that it is that shop window, it is that looking glass into the, like I keep saying, the not too distant future. There's definitely more that we could do. You know, Zed House 2 already would probably be a better version, Zed House 3, and forget it after that, because every house would be Zed House from that point on.
For me, personally, it's been a huge success. Everyone that's gone to the Zed House or worked on it has taken away, I'd say, at least 3 things that they can do better in the future.
Keeping up with housing demand is no mean feat. That said, modern methods of construction provide a real solution to how we can both reduce the construction industry's carbon footprint as well as negotiate the issue of skills shortages. There are still issues which limit the supply of new homes. However, it won't be long until this way of building homes becomes standard across the board. Over this 4-part series, we've explored the home of the future, how it's going to be built, technologies held within it, and how it's going to work with nature. We have already started to incorporate these learnings into our current homes, but there is more to do. As part of the University of Salford's innovative Energy House 2 project, working with Saint-Gobain, we can replicate extreme temperatures, wind and even snow to better understand how our homes can adapt to the predicted changes in our climate. There's never one silver bullet solution. However, by ensuring we're constantly innovating and creating homes for future generations, Barratt Developments will always be best placed to overcome any challenges the future may hold.